writing quadratic equations. They're going to jump right into this. The length of a rectangle is 5 inches more than twice a number. The width is 4 inches less than the same number. The perimeter of a rectangle is 44 inches. Sketch a diagram of this situation and find the unknown number. As in all word problems, we want to define our variables. But in this case, because it's sort of geometric, we want to define this as a picture, right? So we draw a diagram. We show that we know that our perimeter equals 44 inches. We know that the length was 5 inches more than twice a number. So if x is a number, it's 2x plus 5. The width is 4 inches less than the same number, so x minus 4. And now we've actually got our picture. We know that our formula for perimeter is 2 times the length plus 2 times the width. So 2 times 2x plus 5 plus 2 times x minus 4, 4x plus 10 plus 2x minus 8. And we know this all equals 44. And now we can go ahead and solve. All right, so this wasn't so bad. This was just basically a warm-up, making sure you can write the equations and solve. We end up with 7 inches for x. Problem number 2 gets a little more exciting. The length of a rectangle is 5 inches more than twice the width. The area, or the width is 4 inches less than the same number. If the area of the rectangle is 15 inches squared, find the unknown number. All right, so we had the same diagram. That hasn't changed. The only difference is now that the area is what we're looking at, not the perimeter. So area equals length times width. We know area is 15 inches squared. 2x plus 5, x minus 4. Let's multiply this. All right, now that this is multiplied, we now need to solve, right? Remember, our job is to find the unknown number, the x. So we've got to get everything over to one side. In other words, we want to set this equal to 0. That means we're going to subtract 15, subtract 15. We'll end up with 0 is equal to 2x squared minus 3x minus 35. And now we're looking for factors of negative 70 that add up to negative 3. And this one's kind of easy. Remember, you guys can go through this process. So we're looking now for, with these factors, because this is negative and this is negative, the larger of the two numbers has to be negative. And we're hoping that the difference between these numbers is 3. It looks like our number here is 10 and 7. So how about 7 and negative 10? 0 equals 2x squared plus 7x minus 10x minus 35. Let's go ahead and group and factor. I'm going to stop the video to save time. All right, so we've got it factored, and we know that x, or 2x plus 7 equals 0, or x minus 5 equals 0. So we know that 2x equals negative 7, x equals negative 7 halves, or x equals 5. Now remember, is it reasonable for x to be a negative? Not in this case. That means that length there would be negative. So we know that we can eliminate the negative, and we found x equals 5. We could also ask you to find the length and the width, but this question didn't ask that. All right, I'm going to work through a few of these and just post the answers, just show you the answers as we go instead of walking. Well, the first one we will walk through a little bit, but this video doesn't need to be extra long. So in this case, a picture has a height of 4/3 its width. It is to be enlarged so that the ratio of the height to the width remains the same. But the area is 192 units squared, or inches squared, I should say. What are the dimensions of the enlargement? So what is this saying? This is saying that a picture has a height that is 4/3 um, its width. Its width is x. Okay. Um, and these are going to be enlarged um, so that the dimensions remain the same. That's kind of an interesting thing. So let's restate this. If I change this to 4x and this to 3x, do we still remain a ratio of 4:3? In this case, yes. So just by changing the semantics, I guess, or the way we phrase that, we know that the area equals length times width. We know this is 192 equals 4x times 3x. 192 equals 12x squared. X squared is going to equal, I believe this is 16, so we know x equals plus or minus 4, but we know that that can't be negative, so we actually know that this is just x equals 4. So the enlargement we now know has to be 16 by 12, or 16 by 12. So if you will, take a minute and stop the video and try number 4. I'll work it and put it up for you. Okay, so this was a little bit of a challenge in that we had a leading coefficient. My answer ended up being 9 centimeters. In terms of, they're just asking us to find the width. We obviously had to find x, but then we had to go back and find the width. So make sure you go back and say, hey, have I answered the question? All right, so for the next one, remember your ratio, length to width, and if you switch those, you're going to end up with the wrong answer. Um, just you had to multiply through and then take the square root. Once you found x, make sure you answer the question. We're looking for the length. 2 times 5 is 10. Okay, this one's going to be a little bit more interesting because it's a different formula. I'm going to stop the video and work the problem out. I suggest you do the same. All right, so the difficulty in this is understanding and reading. Remember, they said that the second base referred to there, and then they said the height, and the height is the same as the second base. We define that as x. Once that's done, now it's just a matter of plugging things in and getting through this. You can stop the video and take a look at it if you need to a little bit more. Okay, problem number 7 could be a challenge. A garden measuring 12 by 16 is to have a pedestrian pathway that is W meters wide installed all the way around it, increasing the total area to 285 meters. What is the width of the pathway? Okay, so let's think this through and draw this out. We have a garden that we know is 16 and 12. We know we have a pathway that goes around it which enlarges this by W and here by W. So this becomes W plus 16 and W plus 12. And as soon as I said that, I made a mistake. This is 2W, right? Because there's two widths here. 2W plus 12 and 2W plus 16 because there's two widths here. And we know that the area is 285, so let's go ahead and multiply those out. All right, so we know that the path can't be negative. We end up with a width of 3/2 meters or 1.5 meters. And again, stop, take a look at the work, see how you did. We're going to stop for time's sake here. The challenge is again another quadratic, but in this case you have two answers. If you want to work it, 24 by 10 or 10 by 24, if that makes a difference. Good luck.